Hello and welcome to the AI Research Roundup. I am Alex, your host. Today is May 9th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 7 days ago on May 2nd, titled Tempura, Temporal Event Masked Prediction and Understanding for Reasoning in Action. This paper introduces a new framework called Tempura to help AI better understand videos. It tackles how AI models perceive cause and effect and pinpoint when events happen, a process known as temporal grounding. Tempura uses 2 stages. First, predicting missing events and their causes, then segmenting videos into detailed, time-stamped descriptions. Alright, so this first figure really brings the Tempura framework to life. It illustrates the initial stage called masked event prediction, where the model essentially plays detective, trying to fill in missing actions in a video and explain the cause and effect, like knowing you need to clean shrimp before coding it. Then, the figure shows the second stage, video segmentation and dense captioning. Here, the model breaks the video into precise, time-stamped segments, each with a detailed description. This whole process is trained on the new VER dataset, which provides these rich, dense event descriptions. Okay, so to really understand the foundation for this training, this next table, Table 1, compares their new VER dataset with other existing video datasets. What really stands out is that VER offers substantially more video hours, over 18,000, and a higher density of events per minute at 6. Crucially, it provides dense coverage, meaning lots of detailed event descriptions throughout the videos, not just a few sparse ones. And most importantly, it is specifically designed for temporal reasoning, understanding that cause and effect sequence we talked about, a feature lacking in the other datasets shown here. Building on the VER dataset's capabilities for temporal reasoning, this next figure, Figure 2, really lays out the 2-stage training pipeline for Tempura. First, we see masked event prediction reasoning. Here, the model acts like a detective with a video that has a piece missing. It is a type of vision language model, an AI designed to understand both images and text together, and it uses an approach similar to fill-in-the-middle techniques, where the AI essentially predicts what is missing in a sequence, to guess the hidden event and explain the causal steps. Then, the second stage is video event segmentation and temporal dense captioning, where the model takes a complete video and chops it into precise, non-overlapping events, each with its own timestamp and detailed description. Now, to actually create the VER dataset that makes this sophisticated training possible, Figure 4 here details the VER data pipeline. It begins by taking a vast collection of videos, then filtering and organizing them into categories. After that, a powerful large language model, specifically GPT-4o, steps in to generate event captions, so descriptions with start and end times for these videos. GPT-4o then ensures these events make sense sequentially. For valid sequences, some events are masked, and GPT-4o predicts these missing parts along with the causal reasoning, building the rich dataset needed for temporal understanding. Alright, so with that VER dataset pipeline in place, Table 2 really demonstrates the results. It shows how Tempura performs on video temporal grounding, that is, pinpointing when events happen, and on highlight detection. The table uses several metrics. MIOU, or mean intersection over union, measures the overlap of predicted and actual event times. R at 1, recall at 1, checks if the top guess is correct. For highlights, there is MAP, mean average precision, and hit at 1, a top 1 accuracy. Tempura, in the zero-shot tests, meaning no specific retraining for these tasks, achieves a 39.2 mean intersection over union on charade Santa, a notable improvement. Okay, so we have seen how well Tempura performs overall, but the authors also wanted to know, how crucial is that specific 2-stage training order we discussed? Well, Table 3 here really zeroes in on that. It compares the different sequences for Stage 1, which is the mask event prediction, and Stage 2, the event segmentation and temporal captioning. And the numbers are quite clear. Performing Stage 1 before Stage 2 leads to the best results, with a higher mean intersection over union and better recall at 1 scores. so that specific order really matters for performance. So it is clear that the specific training order is indeed vital. To wrap things up on Tempura, the main takeaway here is that by cleverly combining causal reasoning, that is, understanding why events happen in a sequence, with very precise fine-grained temporal segmentation, which means breaking down videos into detailed, time-stamped event segments, AI models can significantly improve their understanding of what unfolds in videos over time. The Tempura framework, alongside the comprehensive VER dataset, really makes these advancements possible. Thanks for tuning into the AI Research Roundup, and I will see you next time.